Hey there, this is Math 6, Unit 5, Lesson 12, dividing decimals by whole numbers. So first of all, we have the number talk on dividing by 4. We're going to divide each one quotient mentally. So 4 goes into 80, 80 divided into 4 groups, so to speak. I know that 8 divided by 4 is 2, so I'm going to assume that 8 divided by 80 divided by 4 is going to be 20 there. 12 divided by 4 is 3, that's not a problem there. Now I do 1.2 divided by 4. I know that my digit in terms of the answer would be 3, but I am moving it the decimal one place to the left. So I'd also move this over here and it was 0.3. And when I look at 81.2, I have an 80 and a 1.2 there. So it's a combination of those two parts, which is going to be a combination of 20 and a 0.3. So we have 20.3. as my solution for 81.2 divided by 4. So let's move into today's lesson here, which is dividing decimals by whole numbers. So first we have using diagrams to represent division. We have 5 tens, 3 ones, and 8 tenths. So it says to find 553.8 divided by 4 using diagrams. Elena began by representing 53.8 like this. So that's our 53.8, right? This is our decimal place is here, dividing apart the ones and tens and the decimals there. She then placed 1 10 into each group, unbundled the remaining 1 10 into 10 ones, and went on distributing the units. This diagram shows Elena's initial placement of the units and the unbundling of 1 10. Let's take a look at what she did here. So we know we're dealing with 53.8 divided by 4. 53.8 divided by 4. So those are the 4 groups. And we can see she had 5 tens, so there's 1, 2, 3, 4, and then here's the 5th one right there. That's our 5th one. She unbundles this into making it into 10 ones. Okay, so she has this hanging out here. Now she still had 3 ones here, and she had 8 tenths. 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay, so what it says to do next, the next page, it says complete the diagram by continuing the division process. How would you use the available units to make 4 equal groups? As units get placed in the groups, show them accordingly and cross out those pieces from the bottom. If you unbundle a unit, draw the resulting pieces. Okay, so how do we keep on dividing up this group here? So first of all, we have these pieces here that need to get put into the groups evenly. So we can keep doing that. We know that 3 is not even, but we can put a 1 there, that's 4. Okay, so we've used that one. And then we have groups of 4. So we have 1, 2, 3, 4. So we can draw them here. 1, 2, 3, and 4. Another 1, 2, 3, 4. So we have 1, 2, 3, and 4. But we have this one extra 1 left. Okay, so we're going to take this 1 and unbundle it into tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we're going to share those tenths evenly with everybody else. The tenths already are pretty even, so let's go ahead and use 4 of them to start with. So here's 4 of them. So 1, 2, 3, 4. Here's another 4 here. 1, 2, 3, 4. So these have all been used up. But now we have 2 tenths left that don't go in there evenly, right? So I need to unbundle these 2 tenths into hundredths. Now, each one is going to be a 10 of something, so we're going to make them into little dots. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these 10 hundredths, okay, these would be our hundredths here. That's one of them. And I have another one, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like so. So those are my 2 tenths unbundled into 20 hundredths. So now I need to take those 20 hundredths and divide them into groups, 4 groups. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we successfully used up all of them as well. Okay, so what we can see in each group has 1 10, they have 3 ones, Now this is our decimal place here. Okay, that's our dividing line there. They have 1, 2, 3, 4 tenths, and they all have 5 hundredths. That's what we can see so far. So the question that comes up next, and number 2, after we've done all the work there, is what value did you find for 53.8 divided by 4? And the value we found was 13.45. Oops, right here. 13.45. Okay. Use long division to find 53.8 divided by 4. Okay, so we did it with a picture way. Now let's use long division, and we're going to verify that that's correct. So we can do that. So 53.8 divided by 4. How many groups of 4 are in 5? We'd say 1. 1 times 4 is 4. Subtract. We have 1 left there. Bring down the 3. We have 13. There are 3 groups of 4 in 13, which makes actually 12. 13 minus 12 is 1. Bring down the 8. As we do that, let's notice our decimal point and add that up there right away. There are 4 groups of 4 in 18. So we have a 2 left over there. We add a 0 and bring it down. And then there are 5 groups of 4 inside of there for 20. Okay, so 13.45 matches what we did with our picture. And that's it. And you can already see how this method here is a little more direct. It gets us the same answer. And we could draw pictures, but it's going to reach the point where drawing pictures takes way too long. Okay? And then can we check it and verify that? Sure. We could do 13.45, and if we multiply that by 4, 5 times 4 is 20, 4 times 4 is 16, plus 2 is 18, 4 times 3 is 12, plus 1 is 13, and then 4 times 1 is 1, plus 1 is 5. Sorry, 4 times 1 is 4, plus 1 is 5. We have 2 behind the decimal, so we're going to move the decimal here 2 spots. And 53.8, which is the same as this right here, 53.8. Okay. Next one, 4. Use long division to find 77.4 divided by 5. If you get stuck, you can draw diagrams or use another method. I'd rather not draw a diagram, but you could if you wanted to. So we have 77.4 divided by 5. I'm going to put the decimal place up there right away. I'm going to add a 0 just because I'm guessing I'm going to need one, and we'll see what happens. How many groups of 5 are in 7? 1. 1 times 5 is 5. We subtract. We have 2. Bring down the 7. How many groups of 5 are in 27? 5. 5 times 5 is 25. We subtract. And we have 2. Bring down the 4. How many groups of 5 are in 24? Just 4. 4 times 5 is 20. We subtract and we have a 4. Bring down the 0. We have 40. How many groups are in there? We would say 8. 8 times 5 is 40. No remainder, and we can stop right there at 15.48. Okay, I'm going to skip the Are You Ready for More for right now, and we'll go to Activity 3, Dividends and Divisors. It says analyze the dividends, divisors, and quotients in the calculations, then answer the questions. Okay, so we have 3 divided by 72 equals 24. We can see we added a 0 to make it 30 and 720. We added 2 zeros and 2 zeros, 3 zeros and 3 zeros. Okay, so even in doing that part there, we notice that our quotient remains exactly the same. Even though I'm making the problem, in a sense, with using bigger numbers, my quotient ends up being the same thing no matter what I do. So a completed sentence in the calculations above. Each dividend is blank times the dividend to the left of it. Okay. So each dividend is how many times the one to the left of it. So this one to the left of it is going to be 10 times more than that one. This is 10 times more than that one. And this one is 10 times more than that one. So each dividend is 10 times more. Each divisor, 3,333, is also 10 times the divisor to the left of it. Okay, great. So this is 10 times that. Okay, so to go from here to here, it's times 10. Each quotient is, in our case here, equal to the quotient to the left of it. Right? They're all equal. So suppose we are writing a calculation to the right of, so this way, of 72,000 divided by 3,000. which expression has a quotient of 24? Okay, so a couple things that you might notice here. Okay, when I did it before, because each part was multiplied by 10, whatever I did to the dividend, I also did the divisor, right? Dividend, divisor, the same thing was done. It's multiplied by 100, multiplying by 1,000. So that means the number of zeros each time is identical. Okay, so here we have 72 with 3 zeros, and here we have a 3 with 4 zeros. So that's not going to quite work out, right? That's going to be multiplying, this is going to be, this won't be any larger. That's times 10 of what was already here. That one stays the same. It won't work. Here we have 1, 2, 3, 4 zeros, and here we have 1, 2, 3, 4, 5 zeros. So it's a 5 and a 4. That's not going to work. Here we have 4 zeros and 4 zeros. So that definitely seems to be an equal increase there. That one has potential. 1, 2, 3, 4 there, and 3 there. Those don't match, so that's going to be different. So we're going to go with this one because you end up with basically 7, 2, 0, 1, 2, 3 divided by 30, 1, 2, 3. And in essence, this cancels, 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 and you're left with 72 divided by 3, which is what we started with to begin with. Okay? Suppose you write a calculation to the left of 72 divided by 3. So we're going to write it over here. We wrote one there. Okay, write an expression that would also give a quotient of 24. Okay, so if we're moving to the left, then instead of multiplying by 3, we would divide by 3. So 3 divided, multiplying by 10 was this way. 10 this way. To go this way, we're going to divide by 10. So what would 3 divided by 10 be? That would be 0.3. And what would 72 divided by 10 be? That would be 7.2. Right? It's moving the decimal one spot to the left. So we would say we would do 7.2 divided by 0.3 because it's a tenth of what it was before. Okay? That's all dividing both parts by 10. Decide which of the following expressions would have the same value as 250 divided by 10. Okay, so 250 divided by 10, we're just thinking about this here, the zeros cancel out, is actually equal to 25. Okay, so 250 divided by 10. But let's look at here. On this one, the 250 stays the same, and now we're dividing by a totally different number than 10. So there's no way that's going to be the same answer. Here, we have 25 divided by 1. Now 25 is 250 divided by 10, and 10 divided by 10 is going to be the same as 25 over 1. That one does make sense. That's going to be okay. Because if I multiply both by 10, I end up with 250 divided by 10. Okay? If I multiply both parts there. And now if that's true, then we look at this one here and we say, well, they both have a 1, but that number is going to be different, so that's not going to be a possibility. Over here, we have 2.5 and a 1. Well, the difference between 2.5 and 0.1 is before I had 25 divided by 1 was okay, right? And we had 250 divided by 10 was okay. And we can see that from here to here, we move the decimal over one spot. And so what's happening from here to here? It's moving over one spot, and this one also is moving over one spot. So that would also be okay. Okay. Now, because I had one spot there, let's take a look here. This is going to be 2,500. Now I started off at 250 divided by 10. If I multiply that by 10, I do get 2,500. Now if I multiply that by 10, I get 100. So this would also be okay. And for this last one here, let's start back off what we know. We know that we could have 25 divided by 1 is going to be okay. And so the difference here is I move the decimal 2 to the left. And if I move this 2 to the left, what I have? 1, 2. That works out great. So this one would also be okay. So we would say B, D, E, and F are all going to be all right there. Okay, so just as a lesson summary, we know that fractions such as 6/4 and 60 over 40 are equivalent because both the numerator and denominator of 60/40 have a factor of 10, so it can be written as 6/4. Both fractions can be simplified to 3 over 2. And 600 divided by 400 is 1.5, and 60 divided by 40 is also 1.5. So just like fractions, division expressions can be equivalent. For example, the expressions 540 divided by 90 and 5400 divided by 900 are both equivalent to 54 divided by 9 because they all have a quotient of 6, and then you can see that they're 10 times the dividend divisor, or 100 times, and it works out to be the same thing. This means that an expression such as 5.4 divided by 0.9 also has the same value as 54 divided by 9. Okay, because both the dividend and divisor are 1/10 of those. So sometimes if you're dealing with decimals, we can compare it to a regular whole number we're familiar with without a decimal, and we're able to figure out what that's going to be. Okay? Alright, so that's it for today. Let's pause there and work on your homework, and we'll come back and check them together in just a minute. Alright, here's a diagram representing a base 10 number. The large rectangle represents a unit that is 10 times the value of the square. The square represents a unit that's 10 times the value of the small rectangle. Okay. Here's a diagram showing the number being divided into 5 equal groups. So we're not worried about place value, it's just how this works out. Okay. If a large rectangle represents 1,000, so let's pretend that this one right here was 1,000. What division problem did the second diagram show? Well, this is the second diagram. So we're going to say we have, if this is 1,000, this is going to be 300, because it's 10 less, or it's going to be 10 divided by 10, 1,000 divided by 10, and this would be 20. Okay, there. So we have 1,320 is what we're starting with, divided into 1, 2, 3, 4, 5 groups. If the first one happens to be 1,000. If the large rectangle represents 100, what division problem did the second show? So if that's going to be 100, then what happens here is we're going to say that we're going to move everything to the left, right? So we move this divided by 100. 1, 2, 3. We'll show you here. Easier. So if this is 100, then this becomes 100 there. This becomes 30, and this becomes 2. So we would say we have 100. Oops, pencil broke. 132 still divided by 5 groups because the groups are still 5. If the large rectangle represents 10, then what division does it show? Alright, let's come back up here. So if this is 10, this becomes 10, this becomes 2 ones, and this becomes a decimal, and 2 there. So, what was 2? Sorry, it's just 3. Sorry about that. So we end up with 13.2 divided by 5. Okay, well, that's it. Alright, okay, explain why all these expressions have the same value. Okay, we have 45, 9, 45, 9. I have 45 and 0.9, and 4.5 times 0.09. Okay, so why do they all have the same value? That's the question they want to know. And then what's the common value? Okay, well, let's do the one with the common value to be the one that doesn't have a decimal. So we'll use this as our common value. 450 divided by 9, which is going to work out to be here. 9 goes into 45 5 times. 45, 0, and how many zeros or 9s are in 0? That, so 50. So the difference from here to here is I'm multiplying everything by 10. I'm multiplying 450 by 10 to get 4,500, and 9 times 10 to get that. Okay? When I go from 450 to 45, I'm dividing by 10, and 9 divided by 10 is that, so those are equivalent there. And to move this over, I'm moving it 1 decimal to the left and 1 to the left to get there. This is also divided by 10. Alright, so we would say that's how they all have the same value. You can see how that works, going from one to the other. In fact, this also is just really divided by 10 as well, and we're good to go. Okay, number 3, use long division to find each quotient. So Let's take a look at number 3. We have 7.89 divided by 2. So we'll write 2 right here. 7.89. How many groups of 2 are in 7? We would say 3. 3 times 2 is 6. We subtract and we have 1. Bring down the 8. How many groups of 2 are in 18? Put a decimal point there. We'd say 9. 9 times 2 is 18. We have 0 left now. Bring down our 9. How many groups of 2 are in 9? 4. 4 times 2 is 8. We have 1 left over, so we don't want to stop there. Let's add a 0 and bring it on down. How many groups of 2 are in 10? There are 5. 5 times 2 is 10. We have nothing left over. B. We have 39.54 divided by 3. How many groups of 3 are in 3? 1. Subtract, have 0 left over. Bring down the 9. How many groups of 3 are in 9? 3. 3 times 3 is 9. We subtract and bring down the 5. And notice my decimal here, so let's go ahead and add it up there real quick. How many groups of 3 are in 5? Just 1. So 1 times 3 is 3. 5 minus 3 is 2. We bring down the 4. And how many groups of 3 are in 24? We would say there are 8. And we can stop there. 8 times 3 is 24. And nothing left over. And finally, we have 0.176 divided by 5. We'll put our decimal point up there right away. How many groups of 5 are in 0? 0. Groups of 5 in 1? 0. Groups of 5 in 17? We would say 3. 3 times 5 is 15. So subtract 15 from 17, we end up with 2. We bring down the 6. How many groups of 5 are in 26? We'd say 5. 5 times 5 is 25. Subtract that, we get 1. Bring down another 0. 5 times 2 gets you to 10. And no remainders, so we can stop right there. Alright, number 4. 4 students set up a lemonade stand. At the end of the day, their profit is $17.52. How much money do they each have when the profit is split evenly? So 4 kids, split that money up. And how do we do that there? Okay, so everybody gets, well, everyone had $17.52, we divide it by 4. So we do 17.52, and we divide that by the 4 people. So 4 goes into 1 0 times. There are 4 groups of 4 in 17. So it becomes a 1, bring down that, decimal goes up. How many groups of 4 are in 15? We'd say 3. 3 times 4 is 12. We subtract, and we bring down the 2, and then there are 8 groups of 4 in 32. So everybody gets $4.38. Number 5. A standard sheet of paper in the United States is 11 inches long and 8.5 inches wide. Each inch is 2.54 centimeters. How long is the paper in centimeters? Okay, so we'll take the 2.54 and we'll multiply it by 11 to turn the 11 inches into centimeters. This becomes 1 times 4 is 4, 1 times 5 is 5, 1 times 2 is 2, 1 times 4, I put a 0 there, we're doing tens now, 1 times 4 is 4, 1 times 5 is 5, 1 times 2 is 2, we add them up, 4, 9, 7, and 2, we have 2 behind the decimal, so this becomes 27.94 for the length, and for the other part, 2.54 times 8.5, 5 times 4 is 20, 25 plus 2 is 27, 5 times 2 is 10 plus 2 is 12, we put a 0 there, 8 times 4 is 32, 8 times 5 is 40, plus 3 is 43, and 8 times 2 is 16, plus 4 is 20. So we have 0, 9, 5, 1, 2, we have 1, 2, 3 behind the decimal, so we'll go 1, 2, 3, for 21.59. So those are my links, 27.94 and 21.590. Those are the 2 links I'm working with there. A standard sheet of paper in Europe is 21 centimeters wide by 29.7 long, which has the greater area. Standard sheet of paper in the United States or sheet in Europe. Okay, so area, we're going to multiply the 2 things together. So in the United States, we would multiply 27.94 by 21.59. In Europe, we're going to multiply 21 by 29.7. Okay, and when we do that there, and you multiply that out, I'm just going to show you the answer real quick. You'd end up with 603.2246 here. and 623.7 there, which means the paper in Europe has the greater area. And that's it for number 5. That's actually it for everything today. Have a great day, and we will see you next time.